Slope, Part 2. Lesson objective: interpret the slope and the y-intercept of a linear regression equation. Lesson objective. Let's begin with a review of the equation of a line. Y equals mx plus b is the equation of a straight line. The x and y values are the x-coordinate and the y-coordinate for all the points on the line. The value of m tells us the slope, which is the pitch of the line, the steepness. And b is the y-intercept. It's the point that crosses the y-axis. In statistics, we think of the value of b as being the initial or the starting point. Now, some software, including StatCrunch, will write the equation of what's known as the line of best fit this way. It's the same thing, except these two terms have been moved around. The b is now the first value that you see after the equal sign, and the term that includes the slope is written second. It's the same thing, but the software likes to write the y-intercept first and then the slope term. One reason for this is this value is the initial, and then this value tells how much to increase or how much to decrease for each increase in the value of x. Let's look at an example. The following scatter plot displays the data for a group of college students involving the variables body weight, measured in pounds, and height, measured in inches. Each of these stars is a student, and each star has an x-coordinate, which is a height, and a y-coordinate, which is a weight. The first question asks, what are the independent and dependent variables? Well, for this situation, height is on the x-axis, so that is our independent variable. For the y-axis, body weight is the dependent variable. So the independent variable is height, measured in inches. The dependent variable is weight, measured in pounds. Question 2, is there a linear relationship between these two variables? Well, just from the scatter plot, these points do look like they have a linear pattern. So I would say yes. Now in statistics, we look at the scatter plot to give us a visual of the pattern, but we also look at something that's called the correlation, and that correlation will tell us if there is evidence of a linear relationship. You'll learn more about that in statistics. So based upon this graph, I would say yes, this looks like a linear relationship. Here is the what's called line of best fit. This is also known as the linear regression equation. Now notice, instead of a y, we're using weight. Instead of an x, we're using height. And notice 80, this is the y-intercept, and what's multiplying the independent variable, that is our slope. So in this case, the slope is 2. So the answer for question 3 is 2, and if we include the units, this would be 2 pounds per inch. We would rise 2 pounds and then run 1 inch. That is our slope. Number 4, the value of the y-intercept is 80 pounds. Number 5, what is the weight when the height is 0 inches? Well, that's the same thing as our y-intercept. It's 80 pounds. Number 6, as the height increases, so as these values get bigger, the weight does what? Well, we see that the weight, the y values tend to increase too. This is a positive slope, so therefore the weight is going to increase as x increases, or as the height increases. Next, number 7, as the height increases by 1 inch, the weight increases by, well, the slope told us 2 pounds. So as the x goes up by 1, the y goes up by 2. Number 8, as the height increases 5 inches, so now instead of increasing just one x unit, we're increasing 5. So now we got to take 5 and multiply it by the slope, and we get 10 pounds. So for every 5-inch increase, the weight increases by 10 pounds. Number 9, as the height increases by 10 inches, the weight increases by 20 pounds. So these are the two important parts to the regression equation, and that is the value of the slope and the value of the y-intercept. Let's look at some templates on how we interpret both these values. So this is the template for slope. So anytime that you have to interpret the slope, you can use this template. And what is written in red can change depending upon the situation. So you always start off as the x variable, whatever the x variable is, that can change, increases by 1x unit. So to interpret slope, we always want to say, okay, as x increases by 1x unit, what is happening to the y? Well, we state that the y variable, of course that's going to change depending upon the situation. It's increasing if the slope is positive, but you say decreases if the slope is negative. So if the slope is positive, y is going to increase. If the slope is negative, the y value is going to decrease. By how much? Well, that is the value of the slope. That is m, and then we put y units. Using our previous example, we would say as the height increases by 1 inch, the weight increases by 2 pounds. Let's look at the y-intercept. The y-intercept is the predicted value of the y variable when the x variable is 0. If you recall, the y-intercept is a point. It will have an x-coordinate and a y-coordinate. The x-coordinate will always be 0. So to interpret the y-intercept from our previous example, we would say the y-intercept is the predicted value of the weight when the height is 0 inches. Let's do another example. Here we have a scatter plot involving two variables, height and shoe size. Now the independent variable is shoe size, the dependent variable is height, and here we can see that this does look like a linear pattern. It's not perfect, and again, most of the points are not on the line, but that's okay. And this question says, what does the point circled in red correspond in this situation? Well, that point tells us that the independent value is 10 for shoe size and has a height of 70. Now, it's not marked here, but the units here on height are inches. So this one point is a student who has a shoe size of 10 and a height of 70 inches. Next, what does the value of 1.631 mean in this situation? Well, if we look up here at the top, this is our equation for the line of best fit, this red line. Notice that the 51.88, that is a constant, so that's our y-intercept, and the 1.631 is multiplying our x, our independent variable, so this value is the slope. We're asked to interpret the slope, and we always want to include the units, so we would say that the slope is 1.631 inches, that's the y units, over 1 shoe size, that's the units for the x. So our rise is 1.631 inches, the run is 1 shoe size. So the interpretation would be as the shoe size increases by 1 size, 1 shoe size, the height increases because it's positive by 1.631 inches. So the interpretation of the slope tells us exactly how much the variables are changing and by the units. As the shoe size increases by one size, the height increases by 1.631 inches. The 51.88 is the Y-intercept, and if we interpret the Y-intercept, we say the predicted value of height is 51.88 inches when the shoe size is 0. Thanks for watching.